if you are interested in staying up to date with latest cloud security news, I encourage you to follow me on my Twitter and LinkedIn accounts. All right, before we can talk about serverless security, let's start from the fundamentals, meaning what is serverless? So I prefer to explain things on the examples. So just imagine that you have a blog. Nothing special, there's just a static content, and this is a blog, let's say, about cute dogs. But one day you see that there are more and more visitors on your blog, so you decided that, well, what about making a profit on it? So you decided that you will sell a course called How to Make Your Dog Love You. And before you become a millionaire, there are some technical problems you have to overcome. So you will put the buy button on your blog, but then you have to somehow handle the payment process. So you need to get the confirmation from the payment provider that someone really paid for your course. And then you would like to automatically send an email to your customer with the URL to your lovely course. And finally, you want to get a report at the end of the day about the amount of all the courses sent in this day. So if you consider solving those problems using the monolithic architecture, the classic approach, then you probably need to refactor whole website. So maybe you will use WordPress, maybe other solution. However, it requires from you some research. Then you don't know how big traffic you will have. You have big expectations about big money, that everyone in every corner of the world will go to your site and buy your super course. However, that's just your assumptions, and based on these assumptions, you need to choose the proper hosting plan. And finally, you have to maintain your server on a daily basis, like care about patch management, about network issues, stuff like this. And if you try to solve those problems using the serverless architecture, that becomes much easier because you can be focused only on providing the functionality. And this functionality can be provided by just several functions which will handle each of the tasks. So let's say you are using the Amazon Web Services. So you are exposing the public API gateway endpoint, awaiting for the payment confirmation from your payment provider. Once it comes, it is validated by your Lambda. So the confirmation comes from the third party, from the payment provider. Then the Lambda function is invoked, and this request from the payment provider is handled, is validated, and if everything is okay, then you are automatically sent an email to your customers with the URL to your course. And finally, at the end of the day, let's say every day at 10 p.m., you want your Lambda to be invoked and to create a report, and then put this report, let's say, in S3 bucket or in dynamodb, whatever. So now you can see that you can use those Lambda functions, which are generally the function as a service. And every serverless application is built from such code of blocks called function as a service. And every provider, every big cloud security provider has their own implementation of the function as a service. In AWS, it is called Lambda function. In Azure, it is called the Azure function. And in GCP, the Google Cloud Platform, it is called the GCP function. And today we will go through the security concepts around those serverless functions. So first thing first, the term serverless is actually pretty bad because there is nothing like serverless. The serverless actually means that somebody else will care about your server that is a runtime environment for your function code. So to prove you, and if you want to play a little bit with the server on which is run the function as a service, you can go to the lambdashell.com website, and you don't even need the AWS account there to play around with Lambda function. So as you can see, it uses. Oops, sorry. As you can see, the Lambda function works on a micro virtual machine based on Amazon Linux image. So basically, it's like a container that is invoked that contains a runtime environment for your code, executes this code, and should disappear. I call it should because there are concepts like the cold and hot starts, but let's stay with the very general concepts of it. So this runtime environment is run on the Amazon Linux image, and the source code of your Lambda function is stored in the var task directory. And there you can see the whole source code of your function. In this particular example, you could see that this is the code of responsible for this reverse shell to this particular Lambda function. Now, from the security point of view, the most interesting are actually the environment variables. So when you print out the environment variables, you would see every plaintext secrets that are stored as environment variables there, but also you will find there the AWS access keys. So those AWS access keys, meaning the AWS access key ID, AWS secret key, and AWS session token, all those three are responsible to, are required to assume the role which is attached to this particular Lambda function. So let's go back to our example that every day, once the Lambda is invoked, it should generate a report and store it in the S3 bucket. And the Lambda has to be authorized to put this generated report in this particular S3 bucket. And to give the permissions to Lambda function to be authorized to put this object there, you need to attach a role to this Lambda function. And those keys like AWS key ID, secret key, and the session token, all those can give you, or the attacker can give you the role, so anyone can assume this role outside the Lambda and has the same permission. So, for example, to put arbitrary content or read the content of this S3 bucket. All right, enough introduction. Let's start with the story I prepared for you today. So I want to tell you a story about the junior developer whose name is Bob. And Bob is responsible for developing few serverless functions and just for internal usage. And this is important because when I'm doing the cloud security assessments, I hear it very often that it is only for internal usage, so there shouldn't be public. So there is no actual need to put any security efforts in those functions, because they are just for internal usage. Furthermore, Bob uses serverless frameworks. So usually developers, when they are developing the serverless applications, they are using the abstraction layer, which helps them, well, makes easier the process of deploying the serverless applications. So as just imagine that you are writing your code of your functions locally on your computer, and then in the very easy YAML format, you are defining all the resources required by your serverless application. So, for example, that you require that there will be created a new S3 bucket, or there will be created a role for this serverless application. All of it you are putting in the serverless configuration YAML file, and serverless framework, based on this serverless configuration file, is generating CloudFormation templates, and based on them, all those resources are deployed in your AWS. The serverless framework uses your local AWS access keys of your IAM user, and also it zip the Lambda source code and put it in the cloud. The first challenge that Bob's received and need to solve is to create the proof of concept application where internal candidates can submit their CVs. So Bob writes something like this. The static content of it is in Polish, but don't worry, it is not important in this demo. The important thing is the URL that you are providing. So you are providing the URL with the doc file of your CV, and there's the submit button, and that's all. So you are sending the URL to your doc CV, and then you are getting from the application, you are getting the confirmation that, hey, thank you, we received your submission, your application, so we'll be in contact. However, if you use a very basic fuzzing, like adding the semicolon in the end of this URL, you will see that in the error message that what actually happens behind the scene. So there's this CV in the doc format is downloaded, and then it is piped to the cat.doc file. So if we put the semicolon here, we actually can inject any arbitrary comment here. So if you remember from the beginning of this presentation, if we are the attacker, then we can, instead of just semicolon, put there the env command, which is responsible for printing out the environment variables. So now you can see the AWS session token, AWS access key, and AWS secret. So and using all those three parts, you can assume a role that is attached to this particular Lambda, and do whatever is allowed by this role. If you want to play by yourself with, let's say, the vulnerable by design Lambda functions, I totally recommend you the Serverless Goat. It's an open source project. You can deploy it in your AWS infrastructure, but be careful. Remember that you are deploying the vulnerable application function. Or you can use the infrastructure that is given you by the authors of this awesome project. So to visualize you, there is the application for the internal usage was accessible via the API gateway. So once the user sends this request with the doc file, then it was possible to exfiltrate by injecting the environment command. It was possible to exfiltrate the roles keys, and then using those roles keys, you can do whatever you want in this AWS account, what is allowed by this particular role. And the over permissive roles are the biggest plug of serverless application, no matter of what provider you are using. So by default, if you are using the serverless framework, you can create just one role for per application. What means it is just one role per all Lambda functions. So let's assume that here the left function really requires all those dynamodb and S3 permissions. However, all those the two other Lambda functions doesn't require it. But if you are using the serverless framework in the default configuration, then uh, then you will create one role that is shared through all three Lambda functions. So if you compromise just one of it, then you are getting the role which has the permissions totally not needed, but you were able to get those permissions. And to fix it, you can use a plugin that is serverless IAM roles per function that allows you to create a role per function. So if there is only, if for example, this function doesn't need big privileges, you are giving the minimum of permissions to this Lambda function, and in this way you are minimizing the potential attack surface. Now, in Azure, when you are deploying the Azure functions, the situation is a little bit different because you are deploying them as logical apps in the app service. So you cannot just deploy just the Azure function like it is in AWS, but you have to also deploy the storage account where your Lambda function is, where your Azure function is stored, and also any other resources that requires this that is required by your functions. And all of those logical apps has the access to the resource group that is assigned to this that is used by this logical app. Furthermore, you are deploying those Azure functions are not separated, but they are sharing the runtime environment. So let me show you on the example. So take a look that here is the demo shell. It is triggered by the HTTP request. However, you have the other Azure function, which is the time-based func, and it is triggered only in the particular time. So let's say every day at 10 p.m. So normally, as an attacker, you wouldn't have access to this function. But if you are able to, for example, inject code to compromise the demo shell function, then you are getting control over all the function, and you are getting the permissions to all resources in this particular resource group. Let me show it on the example. So here I created the Azure Shell demo application. So here it is the name of your logical app, and then after API you can see the name of the Azure function. So here I deploy the demo shell, which allows me to give any command in the CMD parameter. If I will use the command dir, you will see that it is run in the Windows environment. However, it can be also in Azure. You can use also the Linux environment. In the folder home site www root, there are stored all your Azure functions, which are in the different directories. So let's go into one of them. And here you can see that there's the function JSON file where you can see the configuration of your Azure function. So for example, if this Azure function is triggered by a time event, or it is triggered by HTTP, if each HTTP should you give the API key, or it can be invoked anonymously, things like this. And also in this folder, you can find the run CSX file, which stores the source code of your Azure function. So just to show you, let's print out in a Windows environment. You can do it by the type command. So type and the path to the run CSX file, and you can see the source code of this particular Azure function. Now, let's print out the environment variable, which in Windows environment, you can do it by the command set. And yes, what you can do, so just imagine if you have the remote code execution in the Azure function, then you can print out all the environment variables. And as you can see, there are stored all the secrets that are stored in the environment variables. They are in the plain text. We will talk about it later. However, there is also the connection string to your storage account. So once you print out the environment variables, you can just simply copy this connection string to the storage account. And in a moment, I will show you what you can do with that. So if you have the connection string to your storage account, then you basically already compromised whole environment, and you have control over all the Azure functions in this particular logic app. So basically, in other words, this is game over for the victim. Let me show you on an example. So here I'm trying, as an attacker who has the connection string to the storage account, I'm trying to invoke the Azure function that is called pwned. Of course, I'm getting 404 error because there is no such function. So because I have this storage account, then I can use the Storage Explorer, which is the Azure tool. And here, just by pasting this this connection string, then I can see that I have access to those all three functions. And if I upload a new file, a new function, just by upload, and in the pwned there are this as you remember function JSON and the run CSX file, the README of course is not required, then you have immediately access for this function, and you of course can remove the function or override them with the totally new content. So just imagine that all the customers of your victim now, you can inject the code that it will be invoked in the run in the context of your victims. In GCP, situation is also different. So here, let me I set up the netcat listener on the lead port 1337, and then I'm invoking my GCP function to get the reverse shell to the GCP environment. As you can see, what is pretty interesting, that it is running, all the GCP functions are running under the root account. In AWS, in Azure, the account is the user under which they are run is limited with the limited permissions. Here is the pretty interesting concept from Google. If you print out the environment variables, then unlike in AWS or Azure, you will not see any secrets that are related with the role assigned to this GCP function. So you may think, hey, so how the GCP function is authorized to access other entries like the storage resource in your GCP project? Well, surprisingly, every GCP function by default is run under the service account editor role. And the editor role means that you have almost full read and write permissions to all resources in this particular GCP project. So basically, if you compromise just one GCP function, then you can do almost everything in this GCP project with the right permissions, what is pretty scary. So now, how you can access as an attacker with the remote code execution on the GCP function? You may ask, how can you access this role, this editor role? It is stored in the metadata service, and if you are familiar with the cloud technology, the metadata service is always stored no matter of the provider you are using. The metadata service is accessible under the link local address, which is 169.254.169.254. Now, link local means that it is not routable. It is accessible only in the one network segment. So in other words, if you have the shell to this environment, you can access this address. But if you are outside of this environment, then you cannot. Furthermore, to access the metadata service of the GCP function, you need to add the header called metadata flavor Google. So if you have the server-side request forgery in your GCP function code, this is not enough to just access this address, because you also need to put this header. Now, if you do this, then you can let's see the scopes of the role, and as you can see, this is in this endpoint of the metadata service, you can see the scopes of the service account that is attached to this GCP function. And here's the default configuration, what means you are using the editor role. So it gives you the full editor role to editor permissions to the calendar, contacts, Drive, Google Drive, and the cloud platform, meaning all resources in this particular GCP project. Now, what about defense? Well, you definitely you have to follow the least privilege principle, because the over permissive roles, as I said, these are this is the biggest plague of the serverless applications. If you are using the serverless framework, consider using the serverless IAM roles per function. So then you can define the functions just for this, the single role. Furthermore, you can also use the API gateway request validation. What means that if you are expecting in the one of the parameter of the request, you are expecting just the integer value, then in the gateway request validation, you are defining has to be integer. Now, even if you have the vulnerability in your code, this request will not any kind of injection that is not just the integer will be denied on the API gateway level. So it's not even invoke the Lambda, and you will not pay for it. As another solution, you can consider using web application framework that is accessible for all free providers for Amazon, Microsoft, and Google. However, as you probably know, every WAF requires the tuning process. It's not as the super box that you are just enabling it and all the magic is done without any of your effort. In the GCP, you have to, well, at least from the security point of view, you have to consider creating the unique service account to each function, because otherwise you are running every function under the editor role. In Azure, the situation is also pretty tough, because if someone is able to compromise one of your function, the attacker will get the permissions to all the resources in the resource group. So consider applying the role-based access control. So there are no full rights to the resources, but only but in the role-based access control, you can make it more granular. Furthermore, there is something called shared access signature token. So using this token, you can make the your permission model even more granular. And above all, test your code, because no matter if you are using the application, you are deploying application on the monolithic architecture or the serverless architecture, bad code is a bad code. So always remember about testing your released code. Now, Bob received also the second challenge, that another function that Bob should write should solve the following problem. Files uploaded to particular S3 bucket should be automatically renamed with some prefix. So the idea here is simple. If you as the internal user, you are deploying the test new PNG file to the S3 bucket, then this uploading should trigger an event. An event is basically the JSON file where you can find such information as the bucket name or the name of the file that is uploaded to this bucket. And this event should invoke the Lambda. Then the Lambda runtime environment is run, and your Lambda function is executed. So the file is renamed, and the old file is removed from the bucket. Pretty simple. So Bob, like many other developers, didn't want to write the code from scratch, and decided to find ready-to-use code in the internet. So he went through the places like Stack Overflow and npm.js repository. And luckily, in the npm.js repository, he found the package called S3 rename. Analyzing the usage of this package, Bob realized that it is doing exactly what he needs. So he was so happy that he didn't notice that there are just weekly downloads, and this this is pretty fresh package, but well, let's give it a shot. Maybe it can solve the Bob's problem. So Bob wrote the following code. Um, from the event JSON file, he pulled the bucket name. From the event JSON file, he pulled the name of the file that is uploaded to this bucket. And then the new name is created by adding the prefix scanme to the old name. And the magic is done by the S3 rename package. After uploading a file, then Bob realized that, well, actually, it added the prefix. And even more, in the CloudWatch logs, there are no indicators of any error, of any problems. So Bob started celebrating how easily and quickly he was able to solve this task. But if you analyze the source code of the S3 rename package, you would see that there is the obfuscated JavaScript code, which basically is doing the following. It verifies if there is the AWS access key ID in the environment variables. And if so, please send the value of this variable to this IP address using in the key parameter using the get request. And guess what? Guess who's the owner of this server? Uh, of course, it was me, and I created this package just for the demo purpose of this presentation. So this is the reason why I'm stealing only AWS Access Key ID, not the secret and session token, because I didn't want to harm anybody. And with just the Access Key ID, you can do much. You cannot do much. And what was pretty scary was the fact that I received not only access key from Bob functions. So other developers were simply running this package, and indeed there were the AWS access key ID among their environment variables. And there are no any protection mechanisms in npm.js repository that is blocking you from uploading the malicious code. So how to defend? Well, you can run Lambda in your VPC because by default it is run outside of your VPC, and you can put this Lambda in the private subnet. If you don't need that there is any outgoing traffic from your Lambda outside of your VPC, then simply block the traffic using the security group and attach it to the private subnet. Furthermore, if you require any interaction with your internal AWS resources, like for example the S3 bucket, then you can use the VPC endpoints and specify the permissions using the VPC endpoint policies. And similar approach can be applied also in Azure and in Google Functions. Time for Bob's third challenge, that he need to extend his previous code and add some extensions, some filtering of extensions, because only some extensions should be scanned. So Bob, again, instead of creating his own regular expression, he just mixed up various regular expressions, and he created something like this just to filter those extensions. And if we analyze this regular expression, you would see that if the name of the file is test, there's no match, which is good. If test PDF, there's again no match. And test PNG, yeah, there's the full match, which is good. However, if the internal user named the file like this, like many A letters, then you would see the catastrophic backtracking. And the catastrophic backtracking is supported by most of regex engines, what basically means that if there are places like here with the plus sign, that there could be made the different decision about matching or not matching, then the whole process is going to the last point when the other decision could be made. And if there is no match, then again go to the last point where the other decision could be made, and again and again and again. And there are so many attempts of checking that actually that took all the it takes a lot of time and can consume all your memory. And now, if you use and this is called basically the REDOS vulnerability, the regex denial of service. If you apply this REDOS attack in the serverless application, in the function as a service, that actually may create a financial loss for your victim. So if you send such if you loop uploading the file named abracadabra like here for 100,000 times, and each is built for and let's say that Bob created the 15 minutes timeout, then it would cost the victim 1,500 of US dollars. And the denial of wallet can be also, of course, it can be also applied in Azure function and the GCP function. Yeah, you have to also take into consideration this problem, that what if somebody by purpose or just by a mistake would invoke many times of your Lambda, and there is or Lambda or Azure function or the GCP function, then you can pay a lot for it. So what you can do, first of all, if you have the regular expression that you are not sure about it, you can use the website called Redos Checker Search SH, and you can simply just copy paste the regex there, and you would be notified if it is vulnerable or not. And furthermore, you should verify any anomalies in logs. You can also set up the billing alarm that will notify you if your billing is going too high. Time for the Bob's fourth challenge, about that he needs to create the new entry in dynamodb. A very common practice is that developers are putting the secrets as the environment variables. And as you remember, that was possible to print out in every provider environment, to print out the environment variables. So furthermore, if you are using the serverless framework, then all those serverless configuration file based on which the CloudFormation templates are generated, they are stored in the S3 bucket. And this S3 bucket can be read by all your internal users, because there are no any bucket policy that are protecting you that are limiting the access to this bucket for other users. So basically, if you compromise the internal user, or you are the internal user that want to get this secret, and you have only permissions to the S3 bucket, then you can you can see in such bucket all the versions of the uploaded Lambda function. And in the CloudFormation template JSON file, you can simply read all the secrets in the plain text. So always encrypt all the secrets in AWS. You can do it using the KMS service, and also store the secrets in the secret manager or the SSM parameter store. So then you are referring to the secret. So the secret is stored in the secret manager, and then you are referring in the code using the following syntax. So there you never store the secret as a plain text in the in your source code. And in Azure, you can store secrets in the key vault, and in GCP, you can store the secrets in the secret manager. Now, last thing I want to raise are all those dangling resources. And when I'm doing the cloud security assessments, there are almost always the resources that actually shouldn't be there, because they are from the old project which is already dead, or this is just a test of some developers, some teams, but they are still not removed and they are just waiting. And sometimes you can it is an awesome attack vector for entering your cloud, because it is exposed by the API gateway endpoints or other resources. So always remember about removing all not used resources. And if you get the access, then from the attacker's perspective, it is just a beginning. So I encourage you to take a look on my previous presentation about the further steps, what attackers would do, and how to escalate privileges and remove any fingerprints in the logs. That's all from my side. I hope I fixed to the time. So if there are any questions, if there are any feedback, I would be more than happy to answer it.